Okay, so let's start our review of elasticity, which we covered last week. Okay, so first let's cover price elasticity of demand, because this is kind of the big one. You know, it's so preeminent among the other elasticities that typically when people talk about elasticity, this is what they're referring to, and they will actually just call price elasticity of demand, they'll just call it elasticity because it's kind of assumed that it's like the most common one. Okay, so price elasticity of demand relates how quantity shifts when there's a price change. Okay, so how sensitive is the change in quantity to a change in price? Okay, so imagine you had a price change and the quantity, let's say the price changed a lot, the quantity didn't change by very much. Well, then you'd say that the quantity is not very sensitive to price. Okay, and then the shorthand for saying that is the demand curve is inelastic. Okay, it's not sensitive to price. Okay, so when there's a price change and the quantity doesn't change by too much, we call that inelastic demand. Okay. Alternatively, if there's a small price change but a large demand change, quantity demanded change, then we call that elastic demand. Okay. And really the big thing for price elasticity of demand is determining how revenue changes. So imagine you have an inelastic product, a product for which when the price increases by a lot, quantity demanded doesn't change by a whole lot. Okay, it doesn't go down by a whole lot. Right, so quantity demanded should go down when price increases by the law of demand. Right? So if you increase the price by a lot and quantity demanded only goes down by a little, what is that saying? It's saying you're selling at a much higher price to only a few less consumers, right? So if you're selling basically to the same number of consumers, maybe a little bit less, but you're selling at a much higher price, well, you're going to make more money per good. Okay, we call that revenue, the money you make per good, or the money you make overall. So inelastic demand is basically a shorthand way of saying that if I raise the price, my bottom line isn't going to hurt too much. Okay. On the other hand, elastic demand says that if I raise the price, well, a whole bunch of consumers are going to leave my market. They're going to go, buy a competing good or something else, or not buy at all or whatever. Okay, so they're going to leave the market, and even though I'm charging at a higher price, I'm going to lose so many consumers that I'm not going to be able to make the same money back. So when you raise the price on an elastic good, a good that is very price sensitive, you'd expect your revenue, the money you make, to go down. Okay, let me show that graphically. I know I did this last week, but it's the recap, so I feel comfortable doing it. Okay, so I have two axes here. Obviously, quantity is always going to be on the x-axis. Price is always going to be on the y-axis. And two graphs, elastic and inelastic demand, which I have not labeled yet. So what is elastic demand? What would it look like? So an elastic demand curve is going to be very responsive to price. The quantity demanded is going to decrease a lot when the price increases. Sorry, my cat. So it's going to decrease a lot when price increases. So what does that look like? Well, it should be a relative. Oh, I have the eraser on. It should be a relatively flat curve. Okay. So if a price change, if you have a little price change, right? So let's call this P1. Q1, and the price goes up to P2, so even though I don't generally draw to scale, just look at it. the quantity changes a lot, right? Quantity goes from Q1 to Q2. That's a pretty big jump versus this small little jump in price. Okay? And if we, let's do it in blue. If we shade the new revenue, which is the area, so just to recap, revenue equals price times quantity. So the new revenue will equal P2 times Q2, okay? If we take P2 times Q2, graphically, it's going to be the area of this rectangle here, right? Okay. The old revenue will be P1 times Q1 here. And, you know, I guess it's not technically clear, but the way that, like, just because I don't really draw a scale generally, but just taking a look at it, it looks very much like this area here that was in the old revenue but not in the new one is greater than this area here that's in the new revenue but not in the old one. Okay. So we can say, oh, sorry, I don't want to do that. Old revenue equals P1 times Q1, and P2 minus P1 is going to be less than Q2 minus Q1 on divided by their averages just by the definition of elasticity. But basically you're saying P2 goes up by a little, Q2 goes down by a lot. So this whole new revenue is going to be lower. New revenue will be lower than old revenue. Sorry about my cat. She complains about this time. She's trying to wake up her brother. All right, so the new revenue is going to be less than the old revenue for elastic demand because, like I said, the easiest way to remember this is price goes up by a little, but you lose so many customers with the price increase. The customer's like, I don't need this product anymore. I can't believe they increased the price on me. Okay? Inelastic demand, on the other hand, will be very steep. I guess I should label this demand. This is demand. Okay. And when there's a small price increase, let's even try to line it up so that it looks fairly close to the other graph. So P1 should be like around here. P2 should be around here. So if I line out the prices, I mean, I'm not a good drawer, but it doesn't even look like there was a change in demand at all, right? Or I should say a change in quantity demanded at all. Like marginally, right? Well, I drew it as pretty damn steep, but okay, so let's try this again. You guys don't know how many times I've had to record this. God. This is her witching hour, I guess. Anyway, so where we last left off, there was an increase in price on an inelastic demand curve from P1 to P2, and this led to a slight decrease in quantity from Q1 to Q2. Okay, and I was saying that this will have a positive impact on revenue being price times quantity. Because if the price increases by a lot and the quantity decreases by only a little, revenue should increase. Okay, so the nature of the inelastic demand is that a large price change is only going to lead to a small quantity change, relatively speaking. Okay, we can see that here graphically, right? We have a large, or let's say mediocre change from P1 to P2, but the quantity change is so tiny, right? It's almost indistinguishable in the graph where you can't tell where my bad red dots correspond to one versus the other. Okay, so let's take this equation, or this statement over here, and let's suit it to the inelastic demand curve. So revenue is always going to equal price times quantity. That's just the definition of revenue. And the new revenue is still going to be P2 times Q2, represented at this area here, under the red lines to the left and to the top, okay? And old revenue is still going to be P1 times Q1, represented graphically here, right? And we said that this could be the area under the P1, Q1 red line will be the revenue. Okay, but now the change in P2, or the change in price from P1 to P2 is going to be greater than the quantity change from Q1 to Q2. Okay, and these should be in absolute bit values. I should have had that earlier. Okay, it's always going to be absolute value for elasticity, and that's just convention, because of the law of demand. Price elasticity of demand is always going to be negative. So we take the absolute value just to make a, why would you always want a negative number? If you know it's always going to be negative, why make it negative? Why not just make it positive? So we do absolute values on price elasticity of demand. But if you forget them, no big deal. Clearly, I just forgot them. And in fact, I actually recommend that you don't use them at all, because when you do cross-price elasticity of demand and income elasticity of demand, the direction of if there's a negative or a positive matters. It tells you whether something's an inferior normal good or in the terms of income elasticity of demand, or whether it's a substitute or a complement in terms of cross-price elasticity of demand. So I actually recommend, even for price elasticity of demand, to not use the absolute value formula, the absolute value, but I might use it just because it's actually technically like the convention, okay? But the change in price, this is all to say the change in price is going to be greater than your change in quantity. And when you're talking about actual elasticity of demand, you're going to want to, divide by the average, but just for the sake, you can see it on the graph. So the new revenue is going to be greater than the old revenue, because if this one goes up relative to this one, and it goes up by a higher amount than this one goes down, you'd expect the product of P2 times Q2 to go up relative to P1 times Q1. Okay. So your new revenue is going to be greater than your old revenue. Okay. And then lastly, just to tie a little bow on it, if I label this part of the graph A, this part of the graph B, and this part of the graph C, what we can say is that new revenue is A plus B, old revenue is B plus C, aka A is greater than C. There you pick up essentially from increasing the price is greater than the area you lose from dropping the quantity. Okay. All right. So let's move on. Okay, so again, price elasticity of demand tells you how sensitive to price the quantity demanded of a good is. And in general, let's say you have two variables, A and B. Okay, the B elasticity of A is given by like this general formula. So if B is price and A is quantity demanded, you'd say the price elasticity of demand is given by, and then I'm going to give you the formula. Or if B is income and A is demand, you'd say the income elasticity of demand is given by, and then you can plug in for A and B those words and you'll get the formula. Okay, it's just a kind of a general relationship. Okay, so elasticity of, let's say, price elasticity of demand is going to be epsilon sub D for demand, or if it's income, epsilon sub I for income. Okay, so epsilon sub I or epsilon sub A or epsilon sub D or whatever is going to be given by the percent change in A over the percent change in B. Okay, so if it's price elasticity of demand, you'd have the percent change in quantity divided by the percent change in price. Okay, or I'm sorry, Right. I was right. Okay, so you just flip in quantity new minus quantity old over quantity average divided by price new minus price old over price average. Okay, so now's about a time where I would start asking for audience participation. So I'm going to have to ask you to play along in your head. Okay, so we said that if A is quantity demanded and B is price, we have price elasticity of demand. And it's given by A new minus A old divided by A average divided by B new minus B old over B average, where B is going to be replaced with price, A is going to be replaced by quantity, right? And just to bring it one step further, B average is just going to be B new plus B old divided by 2. A average is going to be A new minus A or plus A old divided by 2, right? Your standard average formula. Okay. So let's say I had A as quantity demanded of good 1, and B refers to the price of good 1. Okay, so same good, you have your quantity demanded and price. Okay, I already gave you this one. What is it? It's referring to the price elasticity of demand. Okay, so you'd have the formula Q new minus Q old over Q average divided by P new minus P old over P average. Okay, so that's price elasticity of demand. Now what if I asked you instead, A is quantity demanded of good 1, but B is now the price of good 2. What do you call that? What's the term for how the price of another good affects the quantity demanded of the first good? Okay, we call that the cross price elasticity of demand. Okay, so cross price. The first one was price elasticity of demand when it's the same good. When you have two goods and you want to see how the price of one good affects the quantity demanded of another good, that's cross price elasticity of demand. Okay, you're comparing two goods, you're going across. All right. So what is that useful for? Cross price elasticity of demand can tell us whether something's a substitute or a complement. Okay, and this is why I said in the last video that the overall sign for cross price elasticity of demand matters. Okay, what if I said that the quantity demanded of good 1 rose after price rose? Okay, let me go back to our notepad here. Okay, let me bring this down. Okay, so we're going to say Q, let's call it peanut butter. I don't want to use peanut butter. Let's call it Q good 1, because if I give it Q good 1 and Q peanut butter or whatever, if I give it Q peanut butter and Q jelly, I can't easily switch it from across terms. Okay. So if I have Q good 1 and the price of good 2, okay, let me zoom in. So if I give you the quantity demanded of good 1, it should be specific quantity demanded good 1, and the price of good 2, and I say that QD went up, do the full title, QD good 1 went up, and P good 2 went up. Okay, so it should be this one triggering this one to go up, generally speaking. Okay. Okay, so if we bring that into the elasticity formula, where we have percent change, I can't do the delta on here, but percent change in P, percent change in quantity. See, now I need to refer to the formula. Variable. Okay, so this will be quantity. So percent change in good 1 divided by percent change in P good 2. So the percent change is positive in both cases. So numerator greater than 0, denominator greater than 0, because we have the price going up and the quantity going up, right? So percent change is going to be positive in both cases. So if the numerator is greater than 0 and the denominator is greater than 0, that means the whole fraction is going to be greater than 0. So you can say the cross price elasticity of demand is greater than 0. What does that mean? Okay, so you have a cross price elasticity of demand greater than 0. But think about it logically. What does it mean that the price of good 2 went up and therefore the quantity of good 1 went up? Well, if you think back to the other lectures from before, right, we call this a substitute good. Okay, if the price of Nutella goes up and I consume more peanut butter, we have substitutes. If the price of Macs go up, I'd expect to consume more Dells or whatever. Okay, they're substitute goods, so when one price goes up, the other's quantity demanded will go up. Okay. So having a cross price elasticity demand greater than 0, what does that mean? It means you have substitute goods. Boom. I can't make it bold. I would like to make it bold, but I cannot. Okay. So alternatively, let's say QD good 2 went down because P good QD good 1 went down because P good 2 went up. So let's do the whole formula now, right? So you're going to have Q good 1, QD good 1 minus, we'll call QD good 1 new. Lots of subscripts there. QD good 1 minus QD good 1 old. Okay, divided by QD good 1 average. And that whole thing is going to be divided by, could underline, that would be nice. I know what I can do. This whole thing is going to be divided by QD, let's bring it down just a tad. So this will be divided by P good 2 new minus P good 2 old divided by P good 2 average. Okay. So this portion is always going to be positive. This portion is always going to be positive, the averages, because you're always going to be dealing with positive prices and positive quantities. Okay. What about this portion here? Q good 1 minus Q good 1 new minus Q good 1 old. So I said that Q good 1 went down, so this is going to be lower. So the numerator is going to be negative, right? Because QD good 1 went down after the price change, so the new is going to be lower than the old. So numerator negative. Okay. What about the denominator? Well, the price good 2 went up, so new minus old should be greater than 0. Denominator positive. What does that mean? It means the fraction will be negative, which means that cross price elasticity of demand is going to be less than 0, aka, what does that say? It means we have complements. Okay. Think about it again logically, right? If I consume peanut butter and jelly in tandem with, or if I consume peanut butter in tandem with jelly, and the price of jelly went up, then I would consume less peanut butter. Okay, so in this case, jelly would be good 2. The price of jelly goes up, I consume less peanut butter, so quantity demanded of peanut butter will go down. Okay, so those are complement goods. Okay, so all this is to say is that cross-price elasticity of demand can tell you if it's greater than 0 that you have substitutes, if it's less than 0 that you have complements. Okay. Okay, so where were we? What about if you have the quantity supplied of good 1 as A and the price of good 1 as B? What do you have? Okay, so instead of being price elasticity of demand with quantity demanded, now we have quantity supplied, so what do you think it is? You should be saying it's the price elasticity of supply. Okay, pretty straightforward, right? Finally, what about if it's quantity demanded of good 1? So you should have some type of elasticity of demand, but instead B is income. You guys should be clicking. I hope by this point it's now income elasticity of demand. Income elasticity of demand. Okay. So that'll be Q new minus Q old over Q average divided by I new minus I old over I average. Okay, where I is income. Okay. And what does that tell us? So just like we did with this guy here, we can break down income elasticity of demand, but for the sake of brevity, I'm not going to go the full explanation. But if your income increases and your quantity demanded increases, you're going to have a numerator that's, let's do it here. You're going to have a numerator that's greater than 0, right? This will be quantity. And denominator that's greater than 0 because your income new is minus income old is going to be greater than 0. So your income increased, your quantity increased, your income elasticity of demand is going to be greater than 0. What does that tell you? It means you have normal goods, goods for which when your income increases, your quantity demanded should increase. Okay? Excuse me. Vice versa, if the income elasticity of demand is less than 0, then you have inferior goods, goods for which when income increases, demand goes down, right? This would be, Public Trans, ramen noodles, knockoff products, right? They're all inferior goods. So they would have an income elasticity of demand less than 0.